Hello, student Aparna Vidhate from Brihan Maharashtra College of Commerce, Pune. I teach mathematics and statistics to 11th and 12th standard students. This year, you know that we have revised syllabus. Last year, it was revised for 11th standard. So let us have a look for syllabus. We have two parts, section 1 and section 2. In section 1, we have pure mathematics chapters, and section 2 includes statistical part. Section 1, 8 chapters are there. First, mathematical logic, then matrices, differentiation, fourth, applications of derivative, fifth, integration, definite integration, seventh, application of definite integration, and newly added chapter which is a differential equation and applications. Then in section 2, statistics part, we have 8 chapters. First, commission, brokerage and discount. Second, insurance and annuity. Third, linear regression. 4, time series. Then 5, index numbers. 6, linear programming. 7, assignment problem and sequencing. And the last is probability distribution. So today we'll start with the mathematics 1, that is section 1, chapter number 2, matrices. In this chapter you will learn introduction to matrix, types of matrices, determinant of a matrix, algebra of matrices, properties of matrices, elementary transformation, inverse of matrix, application of matrices. So first of all, we'll start with the introduction to matrix. Matrix means a rectangular arrangement of numbers in rows and columns enclosed in rectangular or circular brackets. Matrices are denoted by capital letters like A, B, C and so on. Here is the general matrix A enclosed in rectangular Aij, where I is the row number and J is the column number. So if you'll observe here, matrix A11, A12, A13, A21, A22, A23, third row A31, A32, A33. So I introduced two new words. One is row, other is column. If you'll observe, horizontal number of arrangements is called row. Vertical arrangement of numbers is called column. So A11, A12, A13, all these are called elements of a matrix. And special elements like A11, A22, A33 are called diagonal elements of a matrix. After this, depending upon number of rows and number of columns, we are going to learn one word, that is order of a matrix. If you will observe these two examples, first B, in B you have 3 rows and 2 columns. That means the order of this matrix B is 3 cross 2, or you can say 3 by 2. There are 6 elements in the matrix B. So while finding number of elements in the matrix, it is nothing but the product of number of rows and number of columns. In second example, C, there are 3 rows and 3 columns. So order of this matrix C is 3 by 3, or you can say 3 cross 3. Number of elements of this C is equal to 9. In matrix C, if you'll observe, A11 is 1. Now what is mean by A11? A11 element is nothing but the element at the intersection of first row and first column. So here in C, A11 is equal to 1. A21 means number at second row and first column intersection. So it's -2. A32 is 6. And you can observe here A33 is 9. So easily if we'll ask to locate the elements of the matrix, you can find out the elements of the matrix easily. Next point we have, which is important, types of matrices. Here are some types: row matrix, column matrix, square, diagonal, scalar matrix, triangular matrix, zero matrix and identity matrix. So let us see one by one. First matrix is a row matrix. A matrix has only one row. Easily we can identify definition from the word row matrix itself. So example is here 3, 4 enclosed in rectangular bracket. So 1 cross 2 is the order. 1 means only one row and 2 means there are two columns. Second example -1, 0, 8 with the order 1 cross 3. Then second column matrix. A matrix has only one column. First example 1, 0 with order 2 cross 1. Second 2, -1, 3 with order 3 cross 1. Then third 0 or null matrix. A matrix having all elements are zeros is nothing but the 0 or null matrix. Example, here is the example with 2 cross 2 order and the other is 3 cross 2 with the entries zeros. Then fourth is square matrix, which is an important type of matrix. A matrix with the number of rows equal to the number of columns. So here first 1, 2, 4, 8 order 2 cross 2 number of rows equal to number of columns. Then the second 1, 2, 1, 0, 1 minus 2, 3, 5 minus 1, 3 by 3 is the order. Then we have a special type of matrix, that is diagonal matrix, square matrix in which every non-diagonal element is 0. Now what is mean by non-diagonal? You can easily locate, these are the red colored positions which are nothing but the non-diagonal elements. Here diagonally we have 4, 0, 0, but the condition should be non-diagonal elements are zeros. Second example is with 2 cross 2 order 1, 0, 0, minus 2. Scalar matrix. Diagonal matrix in which all diagonal elements are same. So like the diagonal matrix, again here off diagonal entries are zeros and the case is only diagonal should be equal 5, 5, 5, or in a second example we have 4, 4 diagonally. Then we have unit or identity matrix. It's again a scalar matrix having diagonal elements as 1. So I2 means 2 cross 2 order identity matrix 1, 0, 0, 1. I3 means 3 cross 3 identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Then we have upper triangular matrix. Square matrix in which every element below diagonal is 0. Now you know that what is mean by diagonal entries, and the below diagonal for upper triangular all are zeros. So here you can locate these are the zeros below diagonal and such a matrix is called upper triangular matrix. Next is lower triangular matrix. Since we know that for upper triangular below diagonal entries are 0, for lower triangular upper or above diagonal elements are zeros. Here are the examples. C is 4, 0, 2, 1. D 2, 0, 0, minus 1, 0, 0. Then the third row is 2, 3, 1. Then we have determinant of a matrix. Already we have learned in 11th standard how to find 2 cross 2 order and 3 cross 3 order determinant. Here we have to find determinant of a square matrix. If A is the matrix with order 3 cross 3, then the determinant of A, we have to write all the elements of matrix in a vertical line format. So here after opening this 3 cross 3 determinant A is equal to 3. After that, depending upon determinant of a matrix, we have one property, that is singularity of a matrix. To check whether the given matrix is singular or not, condition is for singular matrix, a square matrix A is singular if determinant A equal to 0, and non-singular matrix means matrix A is non-singular if determinant A is not equal to 0. This property is important because while finding A inverse, we are going to use singularity property. Here are some examples. Which of the following matrices are singular or non-singular. Using condition determinant A equal to 0 or not, we are going to find whether these matrices are singular or non-singular. So first B, let us find first of all determinant of B. Now you know that how to open 3 cross 3 order determinant. After opening this determinant, determinant B is equal to -2. Since determinant of B is not equal to 0, B is a non-singular matrix. Similarly, you can solve example number 2, that is for determinant C, get the value, check whether the value is 0 or non-zero. If it is 0, then singular. If it is non-zero, then the matrix is non-singular. Whatever we have learned from that, let's discuss following home assignment. Write the type of the following matrices and mention the order of the matrix. Here are some examples. Easily you can get the matrix, order and type of the matrix. So in first case, there is only one column. That means it's a column matrix and order is 3 cross 1. Second, it's a 2 cross 2 order matrix. Diagonally same elements are there. So it's a scalar matrix. Then we have C as a, since there is only one row, it's a row matrix with order 1 cross 3. Then D is nothing but the identity matrix of order 3. Then E is, if you'll observe here, above all diagonal entries are 0. So it's a lower triangular matrix. Then we have upper triangular matrix as F with 3 cross 3 order. And G, if you'll observe here, it's a diagonal matrix since remaining off diagonal or non-diagonal entries are zeros and it's a square matrix too. Then question number 2 is find the determinant of the following matrices. Since you have done already how to open 2 cross 2 and 3 cross 3 determinant, easily you can write these matrices in determinant format and open the 2 cross 2 and 3 cross 3 determinant to get the value of the determinant of a matrix. Then question number 3 is check whether the given matrices are singular or non-singular. Here again for singularity we know that we'll need to open determinant of a matrix. Check whether the determinant is 0 or non-zero. From that you can easily say that the given matrix is singular or non-singular. Then question number 4 is find K if the following matrices are singular. Note that again A is a singular if determinant A equal to 0. In this question, one unknown value we have to find which is given in the matrix, and here given that our matrix is a singular matrix. That means the equation determinant A equal to 0 satisfies. So here write down the determinant of A equal to 0, open that determinant and solve for K. Then we have algebra of matrices. We need algebra of matrices while solving the equations or examples of matrices. There are 5 things. One is transpose of a matrix, then equality of matrix, addition of matrices, scalar multiplication of a matrix, and last, which is again important point, that is multiplication of 2 matrices. So first is transpose of a matrix. To get transpose, interchange rows and columns of a original matrix. It's very easy to get the transpose of a matrix. You have to just interchange the places of rows and columns. It is denoted by A dash or A transpose. Here is the example A with the order 3 cross 2. Then A transpose is just you have to change the places of rows and columns. You'll observe here in A 0 to 5 is first column. In A transpose, it is a first row. And for A transpose, order is 2 cross 3. Symmetric matrix. A square matrix A in which Aij equal to Aj for all I and j's. Example is B. 5, 4, 0, 4, 2, 5, 0, 5, 3 with 3 cross 3 order. Here you can easily locate element 5 in a second row is nothing but the position is A 2, 3. Then a 3-tooth element is nothing but the 5 again. So here opposite number element is equal. In symmetric matrix always A equal to A transpose. If we'll find B transpose for this matrix and check whether equality holds or not. Skew symmetric matrix. A square matrix A in which Aij equal to minus Aj for all I and j. A is equal to here 0, 5, minus 9, then minus 5, 0, 8, 9, minus 8, 0. Here you can easily observe that opposite position element is negative in number. This matrix is with again 3 cross 3 order, but here you have to locate one more thing is diagonally here all zeros are there. So observe in skew symmetric matrix every diagonal element is 0. In skew symmetric matrix always A is equal to minus A transpose. So at home you can write down two skew symmetric matrices of order 3 cross 3 or you can also write for 2 cross 2. Then the third point is equality of two matrices. Two matrices are equal if their order is same and corresponding elements are equal. So here A, B, C, D equal to matrix 1, 3, 5, 4. Then by equality, corresponding position elements are equal. A equal to 1, B is 3, C is 5 and D is equal to 4. Addition of two matrices. Matrix order should be same first of all. To get addition, add corresponding elements. Similarly, we can easily find subtraction of two matrices. So here are the examples. Example A is again 2 cross 3 order matrix and B is 2 cross 3 order matrix. So to get A plus B and A minus B, for addition you have to add corresponding elements. So minus 1 plus 1 is 0, 0 plus minus 2 is minus 2, 2 plus minus 1 is 1, then 3 plus 0 is 3 here, minus 4 plus 6 which is 2, 5 plus 8 is 18. Similarly, you can find A minus B. Scalar multiplication. If A is with order 3 cross 2 and K, that is scalar, which is 3, then K is equal to 3 into the given matrix, multiply by 3 to each element of the matrix A. So here we have K as minus 6, 15, 3, 0, 9, 18. Then the important point from the algebra of matrices is multiplication of two matrices, which is an important operation while solving examples of matrices. A and B are two matrices. Multiplication of A and B is possible if and only if the number of columns in A is equal to the number of rows in B. This property is important. Then only matrix multiplication is possible. You can see if the matrix multiplication is possible, then these two matrices are confirmable for matrix multiplication. Or you can easily check whether the number of columns of matrix A is equal to number of rows of the matrix B. Here A is equal to 2 cross 2 order matrix and B is with 2 cross 3 order matrix. So number of columns equal to number of rows and therefore matrix multiplication or product AB is possible. Whenever you have to find product, you have to check first of all whether product is possible or not. To find matrix multiplication AB and BA, whichever exists here, where A is with order 2 cross 2 and B is again 2 cross 2. Since A and B are two matrices of same order 2 cross 2, both the products AB and BA exist while finding the matrix multiplication, since order is 2 cross 2. So AB product, write down the A and B one more time. Then if you'll observe, start with the first row, first column. Then first row, second column. Second row, first column. Second row, second column. So if you'll here observe how to multiply. First row, first column is 1 into 2. Corresponding position elements multiplication. 1 into 2 is 2 plus 2 cross 4. First row, second column, 1 into 1 plus 2 into 3. Then move to second row. Second row, first column, 3 into 2 plus 4 into 4. Then second row, second column, 3 into 1 plus 4 into 3. So if we'll multiply these things, we have 10, 7, 22, 15. So here is the product AB. Similarly, while changing the position, you can find product BA. So properties of matrices: addition, and for multiplication, addition is commutative. That means A plus B is equal to B plus A. Addition is associative. A plus B plus C equal to A plus B plus C. All these A, B, C are matrices of same order. Identity: A plus 0 equal to 0 plus A, which is equal to A. Here 0 matrix is the identity in matrix addition. And one more thing, 0 is nothing but the 0 matrix. In multiplication case, it's not commutative, which is important property. AB is not equal to BA. It's associative. AB into C is equal to A into BC. Here in matrix multiplication, identity is I. AI, which is equal to IA, equal to A. Unit matrix is the identity in matrix multiplication. So let us take the quick recap whatever we have done in this class. At the end, you will be able to identify the order of a matrix, identify types of matrices, perform fundamental matrix operation. So whatever we have done in this class, we are going to use these all operations to get the answers while solving exercises. Let's just recall what we have done today in our class. We have started with the matrices chapter from section 1. We have done definition of a matrix, then types of matrices, then determinant of a matrix, then we have done singularity property and algebra of matrices. So let us recall how many types are there. Row matrix, column matrix, then square matrix, scalar matrix, diagonal matrix, zero matrix. Then we have a upper triangular matrix and lower triangular matrix. Combining upper triangular and lower triangular, we can see it's a triangular matrix also. That means whenever we are going to say it's a triangular matrix, it's either upper triangular or lower triangular. While guessing how to guess, first of all, upper triangular and lower triangular. In case of upper triangular matrix, below diagonal entries are 0. And in case of lower triangular matrix, upper diagonal entries are 0. Now, how to find determinant of a matrix? Since in 11th standard we have done how to get the determinant of 2 cross 2 order as well as 3 cross 3 order. So by using that method, you will be able to find determinant of a matrix. Only you have to remember that from matrix how to write determinant. Without using rectangular brackets, just you are going to use vertical lines. These two notations are very important because there is a difference in between determinant and matrix. In case of determinant, there is a value for that determinant, and in case of matrix, there is no value associated with the matrix. Matrix is nothing but it's just the arrangement of numbers. Then we have done algebra of matrices. Whenever we have any set of numbers or any set of matrices, then algebra is associated. So in algebra, we have done transpose of a matrix, then equality of two matrices, addition of two matrices, subtraction of two matrices, then we have scalar multiplication, and the last important point is matrix multiplication. So remaining are easy, but in case of matrix multiplication, first of all you have to check whether two matrices are conformable for matrix multiplication. That means the property you have to check, number of columns of first matrix equal to the number of rows of the second matrix. If it is possible, then only we will be able to find matrix multiplication. After this, we are going to say that from these properties, we are going to solve exercises and how to get the system of linear equations. Then even for while finding A inverse or elementary row transformations, we are going to use this algebra of matrices. Thank you.